Okay, so we're working on this reaction. We have NO3 minus,
So cute.
H2TE, we have NO, and we have TeO4 2 minus. Okay, and we're trying to determine if this is an oxidation and reduction reaction. And if it is an oxidation reduction reaction, what's being oxidized and what's being reduced. Alright, Dave, start us off.
Alright, firstly, we can take the first step of figuring this out. So we know that oxygen takes 2 electrons. Right, and we also know that the whole thing has to come out to a charge of -1, and that there are a total of -6 in the charge of oxygen. And since there's only one nitrogen molecule, it needs to balance out to -1, so there needs to be 5 positive 5 electrons.
Yeah, so just to reiterate, each oxygen is -2, and there are 3 of them for a total charge of -6. The total charge on the species has to be -1. That implies that the nitrogen is +5, so that it adds with the -6 from oxygen to make a total of -1. Okay? So that works out. So you're going to identify nitrogen as being +5 in its oxidation state.
Yes.
Good.
And number 2, since we know that this is non-ionic and it doesn't have a total charge, we say 0.
Okay, we can say 0 for these. The equation also works, the question also works if we decide that hydrogen is going to be a bit of a metal here, and hydrogen is +1, and that means the tellurium for the telluride is 2 minus. Either one works, but we're going to go 0 because it'll work. Okay, go on.
Now in this one we can say that, again, oxygen takes 2.
Alright.
And since it's balanced, nitrogen has to lose 2.
That's right. Good.
And now that we can look at the oxygen, once again it takes 2. But there are 4 of them, so the total charge is -8.
Alright, so -2 for each oxygen, 4 of them, so a total charge of -8.
And since it needs to balance out to -2, we can say that there's a +6 charge into it.
That means we got a +6 for the telluride. Alright, so each oxygen is -2, 4 of them makes a total of -8. The whole thing has to add up to -2, so a +6 must be what the other one is. Okay, great. Now let's identify our oxidations and our reductions.
So nitrogen goes from +5 to +2. So it loses 2 electrons.
So it's gained electrons. So this is
Science keep messing me up. It's an oxidation. Or no, reduction.
reduction.
Okay.
The hydrogen was 0.
One little hint that helps us,
There's
a
no
gain
charge
of
over here.
oxygen in this
So that means
species
both of them are
often
0.
means an oxidation of that species. So take a look at nitrogen. Nitrogen is only with one oxygen here, and it's with many oxygens here. So this way it's gained oxygen. Alright? So it's reducing. That's usually the way it works. Oxygen tends to grab electrons. So the more oxygen there are, the more likely you are to be positive if you're paired with it. Alright, and let's look at the telluride.
It's going to be an oxidation because it loses 6 electrons.
That's right. 0 to 6. Now if we're balancing it, we would have to worry about the relative number of electrons. Because now we see that each nitrogen is going to gain 3 electrons, whereas each of the telluriums is going to lose 6 electrons. So we would need to have this nitrogen step twice if we were balancing. But we're not balancing.